So the next topic would be black and white reception. So TV receivers use the super heterodyne principle. In addition, however, there is extensive pulse circuitry to ensure that the demodulated video is displayed correctly. To that extent, the TV receiver is quite similar to a radar receiver, but radar scan is generally simpler, nor are sound and color normally required for radar. It is also worth making the general comment that TV receivers of current manufacture are likely to be either solid state or hybrid. Next would be common video and sound circuitry. So for the tuner, we have the VHF tuner, which stands for very high frequency tuner. It must cover the frequency range from 54 to 216 MHz band. It is the antenna most frequently used for reception is the Yagi-Uda. It is often used as a turret principle. So for the UHF tuner or the ultra high frequency tuner, first must cover the frequency range from 470 to 890 MHz band. Then the antenna used is quite likely to be a log periodic, with the one antenna covering the whole band. Active stages are a diode mixer and a bipolar or FET local oscillator. They use coaxial transmission lines instead of coils, and they are tuned by means of variable capacitors. Alternative means of UHF tuning consists of having var-actor diodes to which fixed DC increments are applied to change capacitance instead of variable capacitors. One of the advantages of this arrangement is that it facilitates remote control channel changing. So basically, there are three things that happen when the VHF tuner is set to the UHF tuner position. First is that the UHF local oscillator is enabled. Second, the VHF oscillator is disabled. Lastly, the very high frequency tuner, RF and mixer tuned circuits are switched to 45.75 MHz. For picture IF amplifiers, the picture IF amplifiers are most invariably double tuned because of the high percentage bandwidth required. As in other receivers, the IF amplifiers provide the majority of the sensitivity and gain before demodulation. Consequently, 3 or 4 stages of amplification are normally used. The IF stages provide amplification for the luminance, prominence, and sound information. If a TV receiver is misaligned or purposely mistuned, the sound carrier may correspond to a point higher on the IF response. If this happens, the extra gain at this frequency will counteract the subsequent 4.5 MHz filtering, and some of the sound signal will appear in the output of the video amplifiers. This will result in the appearance of distracting horizontal sound bars across the picture, moving in tune with sound frequency changes. Video stages. it will be seen that the last picture IF amplifier is followed by the video detector and two video amplifiers, whose output drives the picture tube at various points in this sequence. Signals are taken up for sound IF, AGC, and sync separation. There are two functions of transformer in the emitter of the first video amplifier. First is that it is to provide the sound IF takeoff point. Secondly, the sound IF transformer thus acts as a trap to attenuate 4.5 MHz signals in the video output. This will prevent the appearance of the sound bars. The video amplifiers of the TV receiver have an overall frequency response. The second stage drives the picture tube, adjusting the instantaneous voltage between its cathode and grid in proportion to the video voltage. This modulates the beam current and results in the correct degree of whiteness appearing at the correct point of the screen, which in turn is determined by the deflection circuits. The blanking pulses of the composite video signal drive the picture tube beyond cutoff, correctly blanking out the street retraces. Although the sync pulses are still present, their only effect is to drive the picture tube even further beyond cutoff. This is quite harnessed so that the removal of the sync pulses from the composite video signal is not warranted. The contrast and brightness controls are located in the circuitry of the output video amplifier. The contrast control is in fact the direct video equivalent of the volume control in a radio receiver. When contrast is varied, the size of the output voltage is adjusted, either directly or through a variation in the gain of the video output stage. The brightness controls varies the grid cathode DC bias on the picture tube, compensating for the average room brightness. Now for the sound section. The sound section of a television receiver is identical to that of an AM receiver. Note that the ratio detector is used for demodulation far more often than not. Also note that further that the intercarrier system for obtaining the FM sound information is always used, although it is slightly modified in color receivers. Synchronizing circuits. So the task of the synchronizing circuit in a television receives information in such a way as to ensure that the vertical and horizontal oscillators in the receiver work at the correct frequencies. There are three specific functions of this task. First is the extraction of sync information from its composite waveform. Second is to provide a provision of vertical sync pulses. And lastly, the provision of horizontal sync pulse. For the sync separation, the clipper portion of the circuit shows the normal method of removing the sync information from the composite waveform received. The clipper uses leak-type bias in the load ring supply voltage to perform a function that is rather similar to amplitude limiting. It is seen from the waveforms that video voltage has been applied to an amplifier biased beyond cutoff so that only the tips of the sync pulses cause output current to flow. It would not be practicable to use fixed bias for the sync clipper because of possible signal voltage variation at the clipper input. If this happened, the fixed bias could alternate between being too high to pass any sync or being so low that blanking and even video voltages would be present in the output for strong signals. Horizontal sync separation. The output of the sync clipper is split, a portion of it going to the combination of C subscript 3 and R raised to 2. A positive pulse is obtained for each sync pulse leading edge, and the negative pulse for each trailing edge. When the input sync waveform has constant amplitude, no output results from the differentiating circuit. The time constant of the differentiating circuit is chosen to ensure that by the time a trailing edge arrives, the pulse due to the leading edge has just about decayed. Next would be the vertical sync separation. The coupling capacitor C subscript C is taken to a circuit consisting of C subscript 1, R subscript 1, and C subscript 2, which should be recognized as a standard integrating circuit. Its time constant is made long compared with the duration of horizontal pulses, but not with respect to the width of the vertical sync pulse. For the vertical deflection circuits, to develop a TV picture on the screen, it is necessary to drive the electron beam horizontally across the face of the tube 15,750 times a second, and at the same time move down the screen relatively slowly and then back up rapidly 60 times a second. The two rheostat in the triode rib circuit with the 0.003 capacitor determines the frequency of oscillation and enables the oscillator to be synchronized by the received vertical sync pulses to produce the correct vertical sweep frequency. This is called the vertical hold control. For vertical centering of the picture on the screen, a DC bias can be introduced into the yoke coils by using a center-tapped potentiometer. Centering can also be accomplished mechanically by positioning of the yoke coils. Transistorized vertical sweep circuits may use a multivibrator or a blocking type oscillator that provides narrow pulses at the sweep frequency. The pulses are amplified by a driver stage, and the required sawtooth waveform is developed by an RC circuit at the input of the output amplifier tag. An IC may be used for all the circuitry except for the larger capacitors and the vertical linearity, hold, and height control potentiometers. So for the horizontal deflection circuits, the horizontal deflection section of a TV receiver has many functions. It generates a 15,750 sawtooth current that sweeps the beam across the screen. The same AC that accomplishes the horizontal sweep is also stepped up and rectified to produce the required high aqueduct voltage. A small portion of the horizontal flyback voltage is used to key automatic gain control or automatic frequency control circuits into operation. The multivibrator could be synchronized by feeding a positive or negative pulse to one of its grid circuits. However, any received static or noise pulses could upset the proper synchronization and result in the tearing cut of portions of the picture. So that would be the end of the lecture, and I hope you stayed and listened.